Next, we have a very quick review of isosceles triangles again. We've done something very similar to this part of the page in the past, but let's just review so that we can refresh our memories about the vocabulary of isosceles triangles. We've got a triangle here, and I'll spare you the measurements. DO, I measured with a ruler, and it was 5.5 centimeters. OG was 5.5 centimeters as well. And the angle G was also 20 degrees, just like angle G is 20 degrees, just like angle D is 20 degrees. So let's fill this in. DO is 5.5 centimeters. OG is 5.5 centimeters. The measure of angle D is 20 degrees. The measure of angle G was also 20 degrees. Our conclusion, if you remember from part A, is that the triangle is an isosceles triangle. Triangle is isosceles because two of its sides are congruent. The conclusion from part B is that the base angles are congruent, or in particular here, angle D is congruent to angle G. Angle DOG is 140 degrees because of the triangle sum theorem. The angles of a triangle have to add up to 180. So let's review what are the legs of this isosceles triangle. DO and OG. What is the vertex angle? Angle O. What is the base? That would be side DG. And the base angles would be angle D, angle G. And the base angles of an isosceles triangle are congruent. The reason it's worth going through this very quick review because we're going to have to use this fact about the base angles in a couple of problems that follow. So we have to remember that the base angles of an isosceles triangle are congruent. So let's go ahead and let's start with our first problem here, which is to find the value of x and y. And we have we have an isosceles triangle. And we've got these two sides, the left and the right slanted side are congruent, which we know means that our base angles are equal. So if the base angle on the left is 2x minus 5 degrees, opposite this side, then we know the base angle on this side, on the right side, which is opposite the other equal side, has to be the same angle measure. So we can kind of pencil in here, we've got 2x minus 5 as well in this base angle. Is that enough information for us to solve this triangle's angles? Yes, it is, because we know that the sum of the angles of a triangle is equal to 180 degrees. So we can go ahead and we can solve for x by adding these three interior angles up and setting them equal to 180 degrees. So that gives us 2x minus 5 plus 2x minus 5 plus x equals 180. Let's combine like terms. We've got 2, 4, 5x minus 10 is equal to 180. Adding 10 to both sides gives us 5x is equal to 190, or x is equal to, and I'll quickly just calculate that, 38. Okay, so x is equal to 38 in this case. That means that we've got our vertex angle here is 38 degrees because it is equal to x. But what would our base angles be? We've got to calculate them out as well. Let's go ahead. 2x minus 5 is equal to the base angle. So 2x minus 5 is the same thing as 2 times 38 minus 5. 2 times 38 minus 5 is equal to 71 degrees. Okay, so that means that our base angles, each of them 71 degrees and 71 degrees. Does that look right? Well, 71 plus 71 is 142, and 142 plus 38 is 180. So yes, it all looks right. But we were asked to find not only the value of x, but the value of y. So we found the value of x as 38, but what about the value of y? Well, it got a little, my diagram here got a little messy, but you can still see that y and the base angle are a linear pair. Okay, so the base angle plus y have got to equal to 180. We already know the base angle is equal to 71. So what would be an angle that's supplementary to 71? That would be 109. Okay, so y, therefore, is equal to 109 because it is supplementary to 2x minus 5, which is 71. Okay, so that would be the answer for problem number 5.